What we say when we say that we're going to use the process of elimination to solve a linear system is that we are going to actually eliminate one of the variables. Now we're going to do that by actually adding function 1 to function 2. We could also subtract function 2 from function 1, but what we're going to do is we're going to actually add these two functions together. And in doing that, what's going to happen is we're going to take our 2x and add x, and of course then we will get 3x. We will take our plus y, we will add negative y, so plus 1y plus negative 1y gives us actually no y. So we're not even going to write in any y's because we don't have any left. And of course, if we take 5 plus 1, that means that the other side of the equation will be 6. And by combining these two equations in the system, the two functions in the system together, by adding them, we actually come up with a new equation, 3x equals 6. Quickly divide both sides by 3, and we get that x equals 2. And then we continue with the rest of the story the same way we would with substitution. We will sub x equals 2 into either 1 or 2, whichever one seems easiest. I think that 2 looks easier, so I will sub in the 2 for x, minus y equals 1, negative y equals 1 minus 2, which is negative 1. Divide both negative 1 on both sides, y equals 1, right? Therefore, my solution is 2, 1, right? And I could check by subbing into both equations to verify that my solution is true. Here we have an example of a linear system where the two functions we have, function 1 and function 2, are not arranged the same. So in order for elimination to work, they do have to be arranged the same. So I'm just going to rewrite them in a way so that everything lines up. Not changing what they are, just changing the way that they are shaped, I guess. In this case, I'm going to subtract negative 2x from both sides of this. The y is still there, and that leaves the 12 on the other side. And so I'm, again, going to combine these two functions. I'm still calling them function 1 and function 2. And I will indicate that or communicate that well by somewhere saying that I'm taking function 1 and adding it to function 2. And here we go. 2x plus negative 2x is no x's. 3y plus y will give me 4 y's, and the 6 plus the 12 will give me 18, in which case I will divide both sides by 4, and I'll get 18 over 4, which is a fraction, 9 over 2. I don't fear fractions, so I will just plug then, or sub y equals 9 over 2 into 1 or 2. Let's go into 2. 9 over 2 equals 2x plus 12. 9 over 2 minus 12 over 1, if I prefer, equals 2x. That would be 24 over 2. 9 minus 24 is negative 15 over 2, then equals 2x. I'm going to divide both sides by 2. Get negative 15 over 4 equals x. Not a beautiful solution, but plenty of times we get fractions as solutions. Therefore, the solution is negative 15 over 4, 9 over 2. Now, if you're not sure what I did right over here, dividing both sides by 2, really what I did is I took the negative 15 over 2 and I divided it by 2, which is the same as negative 15 over 2 times 1 over 2, right? Because 2 on the denominator is the same as 2 over 1, and when I divide a fraction by a fraction, which is what 15 over 2 is really being divided by 2 over 1, which is negative 15 over 2 times the reciprocal 1/2, and that's how I end up with negative 15 over 2. Sorry, negative 15 over 4. For this third example, I have another linear system, and as well start by naming the two lines in the system, 1 and 2. If I were to add or subtract these two linear systems together, I don't think anything would actually be eliminated. If I were to add it, right, then my x's would add up to 5x, my y's would add up to 3y, and I wouldn't have eliminated either one of them. If I were to start subtracting one from the other, then that wouldn't help either. I would get some negative values, but one of them wouldn't disappear. I'm going to have to do something to one of them or both of them in order to make put these equations into something that will allow elimination. Now, if I look at linear function 1, I notice that, hey, it's got a y here, and linear function 2 has two y's. What could I do to make them match up so that I could eliminate them? Well, I think I could take the top equation and multiply everything in it by 2, right? I won't change the line, right, as long as I follow rules. And if I do something to the equation, I make sure I do it to everything in the equation. So this entire equation is going to be multiplied by 2, which is going to give me 4x and 2y equals 24. I'm going to keep my second equation the same way it is. Why? Because then I get the same number of y's. And in this case, I'm going to indicate that I'm going to take equation 1 and I'm going to subtract equation 2. Okay, so I have to be careful about that because it might change what happens. 4y minus 3y, or these are x's, 4x minus 3x will give me just 1x, of course. 2y minus 2y will give me no y's. I have an equal sign. 24, careful here, 24 minus negative 12 will give me exactly 36, because it will be actually 24 plus 12. And I will get that x equals 36, and here I can go sub x equals 36 into 1, and I'm not even going to finish it off, right? We've done the rest a bunch of times. I'll find a y value. I could check it, but this was just an example of what to do when we don't have the same variables, the same coefficients in the front of either our x's or our y's. Okay, one final example. Here I have two linear system made up of two lines, line 1 and line 2, and I noticed that just by multiplying one of them by something, I still can't make the coefficients in front line up. So here I have a choice. Do I want the x's to be the same, or do I want the y coefficients to be the same? I'm just going to try and make the x coefficients the same. And so all I'm going to do in order for that to happen is I'm going to actually multiply the top one, line 1, by 2, and I'm going to multiply the second one by 3, right? Really, I'm just multiplying the top one by what the coefficient is here, and the bottom one by what the coefficient is here. And I think if I do this carefully and make sure I multiply everything, most common mistake that students do is to forget to multiply this side of the equation by the same thing they're multiplying everything by. So I'm going to give this a shot here. I think it'll work out to, get my pen, 6x minus 4y equals 10. And 6x plus 9y equals 36. Almost said 12, but in order to eliminate the x's here, I'm going to have to subtract. So I'm going to communicate well that I'm just doing 2 minus 1, right? I might even add a sign there to remind myself. So 6 minus 6 is 0 x's, negative 4y minus 9. Careful, negative 4 minus 9 is going to be negative 13y. And then I have 10 minus 36, right? 10 minus 36 is going to work out to negative 26. Divide both sides by negative 13. and y will equal 2. Nice one, that works out. Right, quickly sub y equals 2 into my choice, 1 or 2. Let's go with 1. 3x minus 2 sub in 2 equals 5. 3x minus 4 equals 5. That means 3x equals 9. X equals 3. Therefore, the solution is 3, 2. And there you go. If you wanted to try one on your own, then the instruction for this would be solve this linear system algebraically using the process of elimination. Give it a shot. Good luck. We'll see you on Monday.